All right, good evening, everyone. Hope you guys have a great day today. Today we're here for this, online workshop to talk about something, everyone's familiar with, which is, just among us. So that's just a virus we're trying to fight with. So today we're trying to, analyze this virus data from a slightly different angle, because I bet you already seen like tons of workshops or webinars talking about COVID, but today would be from a community view to see how neighbors are reacting to the COVID confirmed numbers, and also how to help the policymakers to make the right decision based on the data we collected. Before I start the workshop, let me share the GitHub repository I put together. I just put it on the chat. So this is the repository that contains all the material I'm covering into this webinar or workshop. COVID, right? Everyone do see that the number of confirmed cases it went up, and it gets slightly better. It comes down a little bit after the lockdown, and then we see it climbing up a little bit in some states after the reopening. So have you ever thought about how is your community doing, or how is your community or how your county is reacting to this virus? Because quarantine is not just one person job. We need collaboration from everyone basically. So today we're going to take a look at this community and mobility reports from Google. So it's basically collecting data from Google Maps, so which is the apps I think most people use for if you drive a lot. So then people might say that, okay, hey, that's a reason why I don't want to share data with Google, okay? They just keep collecting everything from my devices, and that's why in Europe they say GDPR just to protect user privacy. Well, I do agree that that is an issue. Privacy is an issue because they can sell the data for, let's say, a geolocation advertisement, which they can make big money out of it. But I think still in this special cases, let's say how the data can help us better understand how the virus is spreading in the country. And so depending on the target audience, and also we might be able to figure out for policymakers, how should they make the right decision, what should they learn from the fact, which is based on the mobility data, like how people are moving, whether they're staying at home, whether they go to work, whether they go to a retail store, these things. So this is the main data set we're going to work on today. So in order to replicate all the analysis, I need to download the original data set from the link I just shared. So it's also on the README file. And I have a data cleaning.ipython notebook. I believe most data scientists or data analysts should be comfortable with the notebook file. It's just you run some Python code, you clean the data. So I call it data cleaning.ipynb. That's just a notebook you use to clean the data, and also you can generate the CSV file we're going to use for the analysis part. Because I didn't upload the CSV file to the GitHub repository because it has a 100 megabytes limit. The original data set just too big to upload to GitHub. So I just put a link here. If you go to the data cleaning part, you will be able to see all the links to download the data. And what you need to do is just put the CSV file in the same directory and just run the code chunk from top to bottom, and that's it. So then eventually you will have all the CSV file we're going to use for the data analysis part. So after that, so today's workshop will be into two parts. So the first hopefully 20 minutes, I'm going to quickly go through the data analysis notebook, which I believe it's just a quick walkthrough of the data set we're going to use in the Plotly Dash app. I believe most people are more interested in the how to build their own Dash app, let's say using the COVID data. So I'm just curious, like, how many people actually have ever used the rshiny package here on the all the attendees? If you have, let's say, used rshiny before, I can just type yes on the chat so that I can, gauge like the, the different background of the audience. So if you ever used rshiny package, it's just Shiny is just a package, a kind of a web application package in R that is, helps the data scientist build a data dashboard, but it's just in a different language. It's in R language. All right, so it seems like most people have never touched it before, but for people who, okay, so yeah, so for people who like, have ever heard of it, it's just very similar to the, rshiny package. The idea is the same thing. So for data scientists, you only use one language. So because before for any front end stuff, you need HTML, CSS, and also JavaScript. Especially the dynamic stuff like the interactive ones, you do need to know a little bit of JavaScript in order to work on that. That was actually a very famous package or framework called D3JS, that you can kind of like write your own like very fancy plots using D3JS. I believe there are tons of courses there, but the idea is the same. So like, for data scientists, instead of like, become a full stack, data scientist, that means learning everything. Try to just limit the tools you use to just one or maybe two, but just stay with one language. So this kind of like a double-edged sword. On one hand, it's very handy. You only need to learn one language, either Python or R. On the other hand, it's sometimes very hard to customize it, the app, when the scope's getting much bigger or when apps getting more complicated. So I will share some of the pros and cons in today's workshop as well. All right, so as I mentioned, for the first part, just let's work on the data analysis. So if you want to do some more hands-on stuff, you can just turn on the Jupyter notebook, and you can open the data analysis notebook file. So otherwise, you can just watch me presenting. All right, so besides the COVID community mobility reports from Google, we also use the COVID-19 cases data set from New York Times. So this is just a repository from GitHub. People might argue that why don't you use the Johns Hopkins one? I think that one has a kind of a one CSV file for every single day. So, but this this New York Times data, they just merge everything in one single gigantic CSV file. It's just slightly easier to manipulate than 100 different CSV files. They can use Globe, to do batch processing, but just being a little bit later, we just stay with the New York Times data. There might be a little bit difference, but in general, you can see the trend is almost the same. All right, so we can read the mobility report CSV file. So for today's workshop, I in the data cleaning part, I just do a quick filter. So we only focus on the United States. So the Google data set is actually, you can see here, it has actually it's a global data set. So that means that the original CSV file is huge. But after data cleaning, we'll only be focusing on the US part, United States part. All right, so the first case is we'll convert the date column to a date format. And then let's quickly take a look at the sample of the data frame that we're working with. This is the, again, this is a Google mobility reports. So we see the, like 9 different columns here. So the first one is the state, then the name of the county, then the date. Then we see like 6 different columns here. So I'm going to explain what the numbers representing very shortly, but these are just kind of like the percentage of the changes compared to a baseline value of the day of the for that day of the week. For example, here, let's say for what's it good for Texas. So this one is like minus 1.0. So that means compared to the baseline time frame, which is January the 3rd to February the 6th. So this is kind of like the baseline time period. So Google just aggregate the data, the Google Maps data within that range, and then compare with that single day. So kind of like let's say on April the 1st, then the retail is like decreased by 1% compared to, I'm not sure the April 1st day, like what day it is, but it's like compared to the same day within that time range, and it's like decreased a little bit compared to the baseline. All right, so you can see that for for this pandas data frame, we do see like a whole bunch of missing values. They're like not a number. So that's just because there's just like not enough data to make a meaningful calculation. I just like too few data points. So you can see that for some of the columns, let's say Michigan, the transit, probably there's like 0 transit data of people just being locked down during May, so that just not enough data points there to make any calculation. So you will see a missing value there. Right, so that's about the number, what does the number stand for. And for each category, or basically the name of these 6 columns, we have retail, grocery, parks, transit, workplaces, and also residential. So I think they're kind of like self-explanatory. For grocery, just the grocery pharmacies like CVS, Costco, Sam's Club, these places. Parks, like local parks, national parks, dog parks, plazas. So transit for sure, like subways, buses in New York City. You have the MTA, and also like you may have like let's say NJ Transit, right? So it's like where I used to take every day. So retail recreation, mobile transport, like restaurants, cafes, shopping centers, theme parks, for example, Disney. And also like the museums, libraries, those are kind of like as the retail and also recreation category. So residential and the workplaces, I think they're quite straightforward, just where people live and where people go to work. So you might be wondering, how do we collect the data? Because if you use Google Maps, you can actually pin the place to be your home or your workplace. So this is like how they find out people whether they're staying at home or whether they go to work, which also means that they're collecting data 24/7. If you agree, because at least on Android phone, you can choose whether you allow them to use the location information when just using the app, or you can allow them to use it all the time, which is not a good choice most of the time. All right, so this is the clean version of the Google mobility data set. So again, you have the state, you have the county level data, you have the date, then followed by the six different categories, each representing a different group of places. And the number here is the percentage of change compared to the baseline data, which is from the January 3rd to February 6th this year. All right, so then we're ready to move on to our COVID data that we downloaded from New York Times. So also I cleaned a little bit before dumping it, before reading it here. But again, you can follow the data cleaning Python notebook. Just literally just need to run every single code chunk, and then you're able to get this COVID cases CSV file. So I believe we downloaded this, I think, last night. So it's pretty new. I mean, it's up to date. And then you can see that for this COVID data set, we have the date, also the state column, the number of cases, and also the number of deaths. So so it's pretty, I think it's pretty standard. But there are actually some missing value because the data is not that clean. There might be a missing value for the state. But anyway, again, we convert the date column to a date format so that we can, if we want to plot a time series graph, we can use the date column as the x-axis. Right, so now we have two data frames, one for the Google mobility reports and the other one for the for the COVID. So now let's try to merge them. But before merging them, so if we go back to the Google mobility reports data set, we see that we have the county level information. Well, there are like thousands of countries in the United States. To make our analysis slightly easier, and case of course I never been to Virginia. I don't know where it's like. Actually, I don't even know how to pronounce this county. So let's just limit it to the state level. And in order to merge with the COVID data set, we're going to group our Google data set by the state, because we only want to focus on the state level data, and also go by the date, because for the for the same day, we only have the daily data for each state. So that's why we group by two keys here, the state and also the date. And then we take the mean of each column. So we just aggregate the numbers within the same state. And then we can take a sample, take a peek at like the data frame after we group by the state and also date. So kind of like for every single state, and also every day you only have one observations. So you can see like, for example, like good numbers here. Like say this is mean, right? So like for June the 5th, the retail decreased a little bit, but grocery shopping actually increased. You can see park is like 176% more than the the baseline data, which means like on that day people just go to park. So you can imagine that maybe like they just reopen, so everyone just thank God we're finally free, so just go to parks. There's some good national parks there. And transit seems to be negative, so like probably they didn't use public transportation because they still feel like it's not safe, so you just drive to the parks. And definitely workplaces is still negative because people are working from home basically, so that's why it's still a negative 30%. And for residential, it's like 8.5%. So which means most people still choose to stay at home compared to the baseline data. All right. So this is just using a sample. So if you run the code, you might see a completely different output. Yes. So I just see the. Sorry, I should zoom in first place. So is it good now? So should I zoom in a little bit more, or this is good? Okay, cool. All right, so now we're ready to merge it with our COVID data frame. So this is our final data frame. We merge with our COVID data frame, and we use inner join so that we only keep the rows that they share in common. And we're gonna merge the two data frames based on the state and the date. These are the two merge keys. Use telltale, that's fine, but so the things like the reason why I prefer using samples, because sometimes you might not be able to spot the issue when you use head or tail, because the data might look completely fine when the first 10 rows, while there might be a whole bunch of issues with the values in the middle. So that's just as my own personal preference, I always use sample so that I can see different chunks of the same data frame. But if you look at how like just after group by, then for each state we're gonna have a date, and then we have the ratio for, let's say, retail and different categories. So you can see here for ASCAT. So on March the 12th, it's like 16%, and then it keeps going down so that people like staying at home, they're not going to restaurants. They're all closed. They're not going to barbershops anymore. So that the number just keeps dropping until like say March the 21st is like negative 31%. And you can see the cases here. On March the 12th, it's only one case, but till March the 21st, like 21 cases there. Right. So here I did actually use a Hive case. I know after the merge, we can see what's going on there to have clear picture. So these are kind of our final data frame. So if you look at the tail, I think that's just Wyoming. So you can see here this data is up to July the 21st. So this is the last 10 rows of the data frame. So that you can see for Wyoming, you can see like on July the 12th. So it seems like things are getting much better. You see like people go to retail stores. So they go to a grocery more often. They definitely go to parks. So they take more transit. Still, people don't go to workplaces. And residential is almost the same because with more people going out, definitely it's like less people staying at home. But anyway, so this is just the data frame. But eventually, we're gonna view all these in plots. So definitely you'll see a clear picture when you see a plot. All right, so this is our final data frame, and we're gonna pickle it. I'm just going to call this app.data, so that instead of loading a CSV file again, if you pickle it, dump it to a pickle file, it's just slightly faster when you're reading as in the Party app. All right, so now let's quickly take a look what pickle is. So pickle is kind of like instead of like so you save the data frame in a kind of a hashable format so that it's only readable by pandas. Because otherwise, so you might use different so-called random numbers or keys to hash it, and then you just keep it in a serial way, so that instead of in a CSV raw file, you kind of like kind of like a zip file, a zip function, so that when you zip a folder, it become much smaller, and then if you pickle it, so the original data is like the CSV, but if you pickle it, it's kind of a much smaller, takes much smaller space on a hard drive. Did that, make sense to you? It just seems like this is a zip file, a zip function. Yes, compress through serialization. Yes, exactly. All right, cool. So so let's quickly confirm the COVID cases trend each state, so that it matches with our our knowledge, and so that we know the data is correct. So we will be first talking about New York State. So here is a quick filter. Our final data frame does state equal to New York. So we only focus on the New York State data set. So it's kind of just a subset. And then we just plot the number of, I think this is new cases. This is just the number of cases starting from March the 1st to like July the 21st. So you can see that I think everyone knows that, during March and May, just New York was the epicenter of the COVID, so that you can see the numbers like is climbing really fast. But now with the lockdown, with everyone's effort, the curve got flattened a lot. So we're getting much better these days. So like there's only like a few hundred new cases per day, but still we do see them because one of the reasons might be people from different other states might fly to New York City or New York State, so that you see the number might climb a little bit. But anyway, you can see the trend is there. Like New York State is getting much better. And then let's quickly check out the mobility trend. So here so this state data frame is just a subset you can see here, it's just a subset of our final data frame that only contains the data of New York State. Then if you look at just New York State, the x-axis is the date column, which is just a time series. And then for our y-axis is using the retail. So once you see like how retail, is trending during the same period, so you can see on March the 1st, people still go to retail places a lot, but after March 15th, like just I think the whole city got locked down, and it started climbing. Some people might go to restaurants a little bit because during the I think the phase. So New York City has like 4 phases reopening plan. I think in phase 2, people can start outdoor dining. So I think it's around like June something. So so that you can see the number climbing up, and so this is like July 2nd and July 3rd. So you can see this this low point here is July the 4th. So I think everyone agree that on that day people would like to celebrate instead of go to retail places. So that's why I see a big negative number there. However, on July the 5th, you can see the number just keep climbing up. So it does give us some sort of like understanding. Hey, the numbers make sense, right? So it does correlate with our understanding. Right, so you can also view all 6 different categories in the same plot as a scalar plot. So all the plots here, I'm using Plotly. So Plotly is the same company or same group behind like a Dash. So they built Plotly package first, and then later on they develop the Dash app or the Dash package. So I would say it's kind of like if you know R a little bit, so it's like ggplot2 to Shiny versus like say Plotly to let's say a Dash app. So if you can get things work in Plotly, these kind of interactive interactive graph, you get it working in a Jupyter notebook. It shouldn't be that hard to kind of like translate it to a Dash app. So this is just a quick way to view the trend of 6 different categories. So that still it's the same New York State data frame, and you can see that for most of the category they're just going down a little bit and moving up. But you can see for the parks, it just it never goes down. So it never went down. So like it's always like above like 20 or 30-ish, and then you can see in written days. It's actually twice as much as that of the baseline time period. Right. So I guess it's sort of understandable because still New York is really cold during March and April, but getting a little bit warmer in May and June. But COVID hit, so people still want to go out because just a nice weather out there, right? So we just couldn't risk that. Okay. So there's a question on the chat. So what advantage are there using Plotly over Seaborn? So it's completely your choice. Plotly is just more interactive. So for example, like you can have these kind of widgets, in a Jupyter notebook, which is not available in Seaborn. But technically speaking, there, as long as your plot is telling the story you want, feel free to use either Matplotlib, Seaborn, or Plotly. Because the reason we use Plotly here because we can either translate the same code or just copy the same code to our Dash app, so that when I expand the Dash app, you don't feel like, oh, what the heck is that code chunk? I never saw this before. So so that's the only reason I'm using Plotly here. But like I mentioned, like feel free to use any plotting package. So the data set and also the notebook is on the Github repository. So maybe Luke or Taras can help me post again. Yes, thanks. All right, so now comes the interesting part. So so like I mentioned at the beginning of this workshop, so we want to see how this how this analysis is valuable to let's say different target audience. For example, like we might be thinking about policymaker. Policymaker is one one group of target audience. So let's see what drives the number of COVID cases. So here we're trying to calculate the Pearson correlation using the correlate method from pandas. So that function actually can handle missing values nicely. So we don't have to write our own NumPy function and do all the manipulation by ourselves. So with the correlate function, a method from pandas, so we can see that. So this is the change in the community mobility versus the cumulative sum of all the COVID cases and also death. So again, and also this is for New York. So it's the state df.correlate. So you get, because I'm going to want a different example after this, and you will see that it's interesting to find out for different state the the numbers look completely different. So for example, we can see that for retail and to the number of cases, it's like slightly correlated, only 0.06. But you can see here for the parks, well, because like I mentioned, you don't see any, so people still want to go to parks. So that's probably one of the reason why there was such a high confirmed cases during during April and May. So you can see the correlation is really high. It's almost 0.6. So the correlation is number between -1 to 1. So 1 means it's highly correlated, positively correlated. -1 means they're negatively correlated. So it means if one number increased, the other number should decrease if the correlation is -1. So for trended, don't see any correlations, probably because just all trended has been locked. So there's no correlation, almost zero correlation here. And then you do see that for workplaces and also residential, at least especially for workplaces. So you do see a negative correlation there. So which means if people don't go to workplaces, you will see less cases, which is good because you don't go to work, so you don't go to let's say Wall Street, in all those buildings, tons of people in a small office, so people will likely get infected. But so that's why the number here, the correlation here is negative, so that if people don't go to work, then the last confirmed cases, which does make sense. So again, this is looking at the correlation during the whole period. So it might be more meaningful to policymakers to look at the data or the correlation number for a certain period. For example, like I mentioned during the reopening, the 4 reopening phases, you might be able to evaluate the effectiveness of each reopening plan, so that you can see that how the reopening is affecting the number of confirmed cases. All right, so that's kind of targeting the policymaker as our target audience. Well, we can also look at data, like say, to check how people from each state are reacting to the COVID numbers. So just like when they see the number on the news, are they still going out? Or they just, okay, so it's so bad out there, let me just stay at home. So like I mentioned, the cases column was a cumulative sum, so which means it's just so we have to take the difference between 2 consecutive rows, so that that's why we're calling the diff method of the pandas series. And then if we take a look at the correlation again, you will see that, for example, here you have the new cases. So this is a new case column that we just created. You can see for the retail, negative, grocery negative, parks negative, trended negative, workplace is negative. But you can see that for residential, it's like highly correlated. It's almost 0.6. So which means, one way to interpret this correlation is when New York people from New York State see the number of cases, like new cases are is coming, is increasing, so they choose to stay at home. So it's just kind of looking at the same correlation from a different angle. Definitely, if you're pitching to policy maker, for example, then you're probably going to use the whole correlation, and maybe you can just pick one, time period. Maybe this is like when the executive order is being executed, so that we can evaluate the effectiveness of this, let's say executive order. All right, so like I mentioned, we can try a different state. For example, I think we have people from Florida, so let's just pick Florida as an example. So you can see for the number of cases, it's a completely different, graph. It was pretty low, number was pretty low, but after the reopening, it just rocketed, to like it's like 300,000. And if you look at retail, so it still goes down because the whole country is being locked down, but it does climb up a little bit. But the value here was actually, I believe, slightly higher than the New York State. And again, you can look at the scatter plot for 6 different categories. So you can see, most of the categories following the same trend, goes down a little bit, then goes up. So you can see the only thing that might be a little bit different is like the residential. So it goes up and then goes down a little bit. So people start going out, when the after the reopening, and then of course the number just rocket high. All right. So if we look at the correlations, so for Florida, so the category that is driving the numbers are the retail, and also the parks. So park is similar to to New York, because I think for New York it's like 0.6, but for retail I think this number is much higher than New York. So I guess Disney is also counted as retail, because retail means theme park as well. So that's why probably this number, why this number is slightly higher than New York State. And then if we look at the cases, the new cases, that's interesting, because so this is the new cases column, and we see that for when we so then when the case number is increasing, so people do kind of like stay at home. They don't go to work, because for workplaces it's a negative number. So for transit it's almost the same. It's 0.02, but still people go to park. Remember, for New York State, all of these 5 numbers, they're pure negative. I mean, they're only negative 0.5, negative 0.6. So it seems like people from New York State is being a, I think, quote unquote better citizen. So like when they see the numbers going up, they just stay at home. Because remember, for the residential, it's like 0.56 something, and that kind of like explain why things going a little bit crazy in Florida right now. I think they're getting slightly better. Yeah. All right. So okay. So this is the analysis we did in Jupyter Notebook, and that'd be the most data scientists are comfortable with this approach. But now let's move on to our Dash app. So how are we going to present the same information in an app? So in kind of like like a web application. So this is what the app going to look like. So you have a kind of a page of introductions, and also you have the other correlations. So I'm going to go through quickly go through the code to show you how to create this app. But before doing that, I'll go back to the README file. Okay, so list how you're going to run the app first, and then I'm going to go through several files to kind of make sure you understand the basic structure of a Dash app, and then you can quickly just take this as a boilerplate. Then you can build your own app. So first of all, I recommend using virtual environment if in Python for any project. So if you don't know what it is, you can just Google Python virtual environment. So kind of create a separate environment for each project, so that if you have, let's say, you have to use a latest version of TensorFlow for the project, but you don't want to mess up with a global Python interpreter. So you can just create a virtual environment for that specific project. and you just initialize the virtual environment. You activated the virtual environment, different command on Mac and also Windows, and then you just install all the packages listed on this requirements.txt file. Or if you just I don't care about the virtual environment, just install all these on my general Python interpreter, then you can just simply cd to the project repository and then pip install all the packages listed on the requirements.txt file. All right, so once you get that done, just making sure everyone's on the same page with the help of either virtual environment or the requirements.txt file, then we are able to run the Dash app. So the index.py file is kind of like hosting the index page of the app. And then once it's up running, you can go to the local URL to take a look. So for example, here you can see this is my URL. I'm not sure if you can see that, but it's just a local host and then a port followed by a port number. This is going to be where Dash is going to hosting this app locally. So next, I think people are more interested in how can you use this sample app kind of as a starting point of your own Dash app. Well, so when I first started in Dash, I think most people will go to this Poly gallery, which does list a good number of fancy apps. But if you click all of them, you're going to see that most of them they're actually just a single page application, SPA, we call it for short. So it doesn't give you a clear picture like how should you structure the repository or the different files when you're building something slightly more complicated. For example, what if I have 2 pages? Okay, so before I jump to the details, there's a question. How does Dash compare with Flask and also Django? So Dash is based on top of Flask. So it's kind of running a Flask application. But Django is a completely different story. It's because Flask is a micro web framework, while Django is like a complete web framework, has a lot of so-called DOM that kind of built-in like classes, built-in like say dependency or different packages are written with Django. So Flask is definitely more flexible and lightweight, and that's probably why Poly choose Flask as the backend. So because for example, in our app, it's I would call this a multi-page application because I really want to build a not just a single page application. So like all the apps on the gallery, is like I mentioned, they didn't show you how to structure the folder, especially if you have multiple pages. So here we do have 2 pages. The first one is the home page, and the other one is like the page showing the correlation. And you can verify that by reading the URL. So for the home page, there's nothing after the port number, but for the correlation page, you do see the / correlation there. Well, this is the layout that I'm most comfortable with, or I'm most satisfied with, because this is like a flat structure, so I don't have to like a rabbit hole. You don't have to like go to this folder and to go to a different folder just to find the definition of a function. So this is the structure that I would recommend. So you have the app.py, which is where you're going to initialize a Dash instance. And then the index.app, like I mentioned, is the entry point of your Dash app. And then you have the layouts.py, that just define the layout of each URL, each page, or basically just how your app looks. So next we have the callback. This is the where you define how to render the output when the input changes. For example, in our example app here, if I change an input, which is going to be this drop-down menu, so how we're going to change the cars and also the, let's say, the pause. So all these are defined in the callback file. Then you have requirements.txt and also assets. So this is just a folder contains all the static files, like in a JPEG file or in a favorite icon, which is like this little icon here, for the GitHub one. So all those static files goes to the assets folder. All right, so for the layouts.py, maybe we can jump to the code a little bit. So for all of these, when we're developing this application, we are using 3 different main packages. They're dash core components, dash HTML components, and also dash bootstrap components. So these kind of the only 3 packages you're going to use when you build the layout of the app. So what do they do? Well, so for the layout, so for the HTML components, those just contains basic HTML elements like h1 tag to h6, h1 tag, or in a div tag, or in a p tag. So if you happen to do in a web scraping before, you might notice that this is just a this HTML element that representing each different section of the page. But if you haven't done this before, no worries. It's super straightforward. So p tag just means paragraph. H1 tag means header 1, and just make the the size of the font slightly bigger. And then we have dash code components. So this is a interactive component written by the Dash team. So instead of those basic HTML elements, they are like more interactive. So if you go to the documentation page, you will see that so you have drop down, which is the one we used. You also have slider, range slider, input, etc. So this is like just slightly more interactive than the basic HTML documents. And then eventually you have this dash bootstrap components. So this is the part that makes your application like looks nicer. So it's not like Craigslist, right? So we all know that it has a very 80-ish design. So it looks like your browser, your internet was wrong, right? So so with the bootstrap, that's a part that I can mention. It's kind of like the some drawback of using Dash. If you want to build some more complicated web application, you want to make it look nicer, you have to use some so-called CSS file to kind of change the how each component looks. You want to make a different color, you have maybe a different shape. So those are defined in so-called CSS file, in front-end development. But thanks to another team, I don't think it's maintained by the official policy team, but the Bootstrap component is like another cool package that kind of like connect the Bootstrap CSS or Bootstrap design with the poly or with the Dash components, so that makes our life a lot more easier. All right, so when you look at the layouts file, so like I mentioned, this is where you define the structure of your app, and when you're developing something more complicated, this file can get really messy, which means like you have to align all the not curly braces, but you have to align all the parentheses and also square bracket, so that sometimes really it can kill you, like how come this is like an index error, how come that's a syntax error. So that's why I highly recommend using this, which is so-called VS Code, Visual Studio Code, VS Code. So you can see I'm also a Sublime text user, but after switching to VS Code, I can see I cannot go back anymore. I have all my settings in the Sublime text. That's kind of like I was a little bit reluctant to move to VS Code, but now I try it for just like 1 week. I think it's super awesome. So I highly recommend you to try it if you haven't. This is just called VS Code, developed by Microsoft actually. So they have this so-called what's it called, bracket colorizer. So just like helping you identify the different scope of each function, and also each let's say this is like the list, so you can see all the square brackets in the same color. So it can help you complete your code. Okay, sometimes when code getting really long, for example, our layouts of Python can give you a quick look. So you can see it can get really messy, really long. so that you might get lost, like say where I am, right? So with those, highlighting, it's really helpful for you to get, to avoid some like silly errors like syntax error. All right, so that was my son. So if you overheard anything, I apologize for that. So let's go back to our code. I think that's everything we need to know before we jump into the code. I will just quickly go through. You don't have. I'm not going through every single line of the code. I do want to give you a big picture, of like how to come up with our own app. All right. So we define the app in the app.py, which I'm not going to go over. It's just one line of code. So then we define the layout of the app. It's the div tag from the HTML, and you can see that we have a location, DCC, which is shortcut for dash code component. So for any multi-page application, you need a location. And then you have the sidebar layout that was defined in our layouts. Like I mentioned, the layouts file contains all the layouts of each page. And then you have the so-called page content. I call it page content here. Okay, so if you go to our app, so this app is mostly composed of like two different parts. So you have a sidebar that doesn't really change. It might change the highlight, but it doesn't really change if you jump to a different page. But you can see on the right-hand side, you do see that we have we got that part got updated based on where you click. So if you go to home page, that's just a short introduction. If you go to the correlation, that will show you the 6 different cars and also the 2 charts. All right, so then I'm going to talk about this callback. So for people work with Python for a bit, so you might recognize that this is a decorator. So decorator is just a function that takes function as input, and this is something called decorator with input arguments. So that means when the callback takes this function as the input, it also has access to the input and also the output. So I think the input and output, they're quite straightforward, because the input means it's going to trigger this callback function whenever the value of the input changes, and then it will return the output based on the input value. So what does that mean? Okay, so let's take a look at this very first callback. It has it's an input, and the first one is so-called the ID, which is the ID of our location variable here, and then the second one is so-called the property of that component. So if you look at the location class, so there is a attribute called path name. So location kind of like taking care of all the URLs, and then you have so whenever that changes, you're going to trigger this callback, and it's going to render a different output. So for example, this is the output that has ID equal to page dash component, which is the div tag we just defined here. So you're going to update the children property of this output that has ID equal to page component. So what does that mean? So if you go to the definition of the div, you can see that the first property is called children. That's just a list of dash components, or simply just Python strings or numbers. So it's kind of like tree structure. For each div or each component, it could have, like, say, nested components. So it kind of like the quote-unquote children of that a div component. So based on the different URLs, I'm going to return different component, different output of the right-hand side of the page. So you can define. So when the function, you can define, you can name it however you want. It doesn't really matter, but the number of arguments should be equal to the number of input arguments should be equal to the number of inputs in the callback function. So depending on the what the path name is, so for example, if it's slash, so that means that's a home page, then we just return home page layout. So home page layout is a layout we defined in the layouts file. And then if the path name equal to correlation, so that means when we go to the correlation page, so you can see, I'm not sure how to zoom in, but I think it's going to zoom in the URL, but you can see the URL here is /correlation. So that means, when we go to that page, it will return the correlation layout, which is something we defined in our layouts file. Well, if not, if we didn't recognize it, then we just return a full page. So basically, if you type, anything here, that would be just a full page. All right, so let me jump to the layouts, because I do want to wrap up in like maybe 8 minutes. So like I mentioned, layouts is like where you define the structure of each page. For example, we have the homepage layout. That's just eventually that's just a markdown object. So you can see here, everything I typed on here will be, it's just a markdown language. So you can also see that's basically here, all the introduction part. So like I mentioned, if your app is getting complicated, this layouts file will getting very messy, but still it's still better than just to make this index file a gigantic file, so that it's very hard to navigate through the different chunks. So I would rather just keep all the layouts in one single file. So so that's basically it. I mean, so for this is the sidebar layout, and we have the correlation layout, which is how we define how this correlation page is going to look like. So we have 6 different cards showing the correlations, and then 2 different graphs, which is the exact same thing we saw on the Jupyter notebook. Right. So for example, this drop down, we have an ID called equal to state drop down. So they just an identifier can help us find what exactly the input is. And then, for example, here you have the HTML.h3 tag, which means this is a header 3. So just like a kind of a title. And then, for the graphs, they just a graph object from the core component package, and then we call the first one line chart. Just give an ID so that when I introduce them in the callback, you still remember these 2 IDs. And then for the second graph, I call this trend chart. So this is just a ID of the chart. So then we're going to see how we're going to render these 2 plots in our callbacks, because callbacks is like how we're going to render the output based on the input value. So let's look at just the first callback. So again, this is the same app.callback, and it takes 1 input, which is the state drop down, and we're taking the value property of that drop down. So we go to the layouts, and we can see here you have the ID equal to state drop down. So that means whenever that drop down value changes, we're gonna render the chart. All right. So then for the output, we have 2 outputs here. So based on the input value, I'm gonna render 2 different figures, correspondingly. So the first one is line chart, and then the output is the figure property of the line chart. For the trend chart, it's the same thing. I'm gonna update the figure property of the trend chart. So I'm not sure if we can see here, but yeah, probably not. But anyway, so because these are like graphs, so it's a different property name. So instead of being a value of the drop down, we're updating the figure property of the chart. So then we define the function how we're gonna render the chart. So we have to just display line chart, and the number of input arguments should be equal to the number of inputs. So you only have one input here, so then that means your function only takes one input argument. And then this part is exact same thing as we did in the Jupyter notebook. We just do a quick filter. So df.state equal to value. So the value comes from the job done. So it's basically the same thing as we're saying, hey, basically this line. So like final df.state equal to Florida. So instead of just stating like this is Florida explicitly, we use the value of the variable equal to value, which is the value coming from the job done. So that's exact same line. And then here we're looking at the new cases. So we take the difference of the two columns. And then here you can see for the return statement, we return two different objects because we have two different charts. So the first one, the line chart, we use the state df, actually to date, y equal to new cases. While the second one is the scatter plot. So these two lines are exactly the same as our Jupyter notebook. So you can see here, this is a poly.line state df x equal to date, y equal to retail, while this is the code for the scatter plot. So like I mentioned before, this is like once we get everything down in poly, you can easily translate to a Dash app by just copy pasting them into the callbacks script. However, I think for most data scientists, you probably need some time to kind of like get a better understanding of this of the layouts, because like I mentioned, even if you're using, let's say, Bootstrap components, still you have to see how they're connected with the Bootstrap CSS file, so that okay, so if I change that property, it's gonna, let's say, change the color of, let's say, the card. For example, here our app, if this is a negative correlation, we can change the color to red. Otherwise, if it's positive correlation, the color is green. So in order to know how to change that color, you do need to dig into documentation a little bit. So that's why I mentioned, to build a simple application, you can literally copy the code from the gallery. You can just pick the fancy one that you're going to use. But still, if you want to customize it, there's like slightly steep learning curve. You have to study HTML, CSS just for a little bit to understand what's going on there. But overall, I think Dash is a great tool for data scientists to present your findings instead of a notebook. Because I know a lot of data scientists, what they do at work is like you have to present to different team members or to the executives, and they don't understand what the heck did that code mean, right? So they only know like how do I read the plot, how do I read the graphs. So in order for data scientists to build a Dash app from scratch, or just a dashboard from scratch, I think Dash is a great tool. And we're going to teach that in our new bundle as well. All right, cool. So yeah, so I'm just I'm almost done with my material. So let me just jump back to the questions. So it seems not much customizable than Ipython widget than the yes. So Ipython widgets is kind of like add-on to the Ipython notebook or Jupyter notebook, but still it has its own limitations. So that's why so especially when you're trying to present something, I don't expect you presenting this to a boss or to a manager. So it's better if you have something much cooler, something like they're more understandable. How do you upload this app to a server? So great question. So you can either choose to rent your own Amazon Web Service EC2 instance, or you can sign up for websites like Heroku, which is kind of like a one-stop shop for like deploying your app. There are tons of tools. So it's actually just Google, let's say, how to deploy Dash app on Heroku. Then you'll find a bunch of tutorials, and literally just like one line of code, and then just Heroku login, Heroku push, because we actually use Heroku internal as well. So so I recommend using Heroku because it's just a one-stop shop for deploy for dev work actually. So let me just going back to other questions. Okay, see, Luke has to go. PyCharm is also great. Yes, you can see I should have PyCharm here, but I guess I'm gonna move to VS Code moving forward. All right, so let me stop sharing and try to answer more questions from the chat. Okay, so do you recommend using a virtual environment every time you start a new project? It depends. So if I just realized that my camera is not properly positioned. But anyway, so it depends. So like if I know this is a data analysis project, which means it's going to use pandas, maybe Seaborn, maybe NumPy, and then I know I'm comfortable with the version controls, then I probably won't start a new project. However, if this is something specific to, let's say something the client requires, or like you're gonna mess up your system, when you're working on this app. Because one I experienced when in the long history of like my development with Python is like sometimes just trying to install one single package, it's gonna mess up the whole thing. So I have to literally like, okay, just let me just restart over. Like it's not gonna work. So if that this project involves like packages like I don't know, like maybe TensorFlow or PyTorch, these packages, they're like more version sensitive. So which means a function might work in one version but doesn't work in different one, then you probably want to create a virtual environment. But like I mentioned, it depends. So like for general data analysis project, I don't really create a new virtual environment. Does Dash work with dynamic data, say like stock market data, which gets updated every minute? Yes, I believe so. So at the end of the day, it's a Flask app, so everything can do. Oh, it's a Python application, so everything can do in Python, you can do it in Dash. So which also means, for example, I guess you're talking about say Yahoo Finance API, which you can make API requires every minute. That's definitely doable. So in your app, you kind of like need a kind of an infinite loop, right? Every minute you make a request to the API, you pull the data, you update the app. So that's definitely doable. So let me look at code. Question: Do most data analysis in Jupyter notebooks, then copy paste reusable code into BallPy to create modules and packages? Great question. So I think Jupyter Notebook itself is a great tool to exploring data set. And to be honest, I use it, every time I get a new CSV file or every time I need to use a new package. So for example, here, for the first time I use Poly, I don't really know what they're talking about. Like, how do I know the different, input arguments of each function? Then I just, move my cursor inside the function and press Shift Tab. And then, without going to the documentation website, which I believe some people prefer, but I personally don't really want to go to the documentation page every single time just to look up how to use this, px.line, function, because I can literally just say, okay, so I know the first three, are the most, important argument. I know the first one is data frame, x and y, which means the x and also y axes. That's enough for me. So I don't have to know, like, because otherwise, if you ask me to start from scratch, I don't know what to type here, right? So that's how I use Jupyter Notebook. But so if you want to code to go to production, for example, like you want to deploy code on a Linux server, then you do have to move all the reusable code into the .py files so that you can just either build your own package, or like you just have a cron job, right? So you run every single minute, like the one we just talked about. How can you check marks as example for a specific date when the quarantine began in a specific region? Is that feasible? Do you guess this kind of milestone as information? Okay, so how you can check what marks or masks as example for a specific date. That feasible. Okay, so so I think you can. So I didn't build a slider there because I know I'm not gonna have time to cover everything. But you can actually use the slider to kind of like do a quick filtering. So it's kind of the same thing in pandas data frame. You know, you have the date column, so you just say everything greater than a time, a date time less than another date time, and then you can look at a single, a single period of time, so that you can compare the results. I didn't do it here, but that's definitely doable in Dash. All right. Do you always put the layout callback in separate files? So like I mentioned, this is the way I feel most a most reasonable way of doing multi-page app in Dash, because you can. So I think on the documentation that you can either put so they're like a nested structure or a flag structure. I think either way works, but at least this structure makes more sense to me, because layouts basically means all the layouts of the pages. Callbacks means how do I handle all the interactive stuff. How do I change the output based on the input. Index is the entry point running the app. So because one thing I personally experienced was like every time I have to let's say look at other people's code, right? So there's a new package. You want to study how this package works. If there's like nested directory, just if I just want to export on GitHub, well, I have to, okay, I see they define function X here. Well, they import it from another script. Okay, so in order to find that script, I have to go folders up, and go jump to a different folder just to find the definition. I think GitHub has a new feature helps you actually show the definition, but that's a new feature from GitHub. But anyway, I think in general, I would like to keep a simple structure, just either for me to debug, because otherwise if you have a nested layout or a nested structure, in order to find the file, you do need to kind of like okay, I need to expand that folder, go to that file, and find what's wrong there. So this is like I mentioned, this is like just the way that I feel most comfortable with. And it's actually recommended on the Dash documentation. So it's either like you have nested layout or you have a flat layout. Sure, no problem. All right. So any other question from the audience? All right. So if there's no question, I think I'm ready to share my son. So I guess we'll see you guys next time.